can see you, everyone.
Hi, good afternoon, everyone. Well, first of all, welcome you all. Come to the Actuaries Institute. It's our pleasure to host all of you guys. So we are the Actuaries Institute, and we actually work really closely with a lot of data scientists, and we're very excited to have future collaboration opportunities with you all. And I'll pass to Eugene.
Thanks, Meg. So welcome one and all to another exciting episode of Data Science Sydney. And on that point, as mentioned in last month's event, we're looking to change the title. We're looking to put AI in the title. We're looking to make AI prominent. And that all sounds great, except when you think about what the acronym Artificial Intelligence and Data Science could stand for, is probably not very intuitive. So suggestions are welcome. Suggestions are welcome. We're still thinking about it, but a name change there will be, especially given that just about every session we have now, at least one of the talks will be on AI, as indeed is the case today. Should also say that today we had the largest number of RSVPs we've had in this incarnation of Data Science Sydney here at the Actuaries Institute. We're very, very grateful for the wonderful venue and the food and the drink. So largest number of RSVPs, possibly the largest number of attendees as well. And I'm actually very curious regarding the attendees, in particular regarding the attendees' purpose of being here. And my first question is, what proportion of you are here for the very first time? All right. The other question I have, of the ones who are here for the first time, how many are here for the careers-oriented talk? And how many are here for the AI-oriented talk? And now, the same question, but for everybody. So those who are here for the first time get to answer again. How many overall are here for the careers talk? And how many for the AI talk? Way more. How many are here for both? Okay, that's very interesting. Thank you. That's very good feedback. So I mentioned the name that's coming. I did mention I asked you questions about your being here. So that's very interesting. So yeah, all the more reason to make this a much more obviously AI-focused group, as it pretty much already is. The only other thing I should mention is when the talks have finished, please don't jump up and run away. We have announcements and a few other things at the end after both speakers have finished. Now, the other reason this is a bit of a first, we've had some very interesting circumstances around this particular event. So, as I said, we have our biggest number of RSVPs, which is great, and seats are almost full, which is good to see. But we also had some unforeseen circumstances. And the first unforeseen circumstance was that our first speaker, the speaker on the AI topic that many of you have come to see, turned out to have to go on a sudden business trip. Now, does this mean that he's not presenting? It does not. The presentation will go ahead, but remotely. So Dimitri will present remotely. Thankfully, he was able to make the time for that. We're very grateful to him for it. And then, just as I thought, okay, we've got that sorted, yesterday I got a call from the second speaker who told me he had COVID. And then I thought, okay, no second speaker. But fortunately, the inestimable Luke Metcalf, there he is, who is, like Dimitri, a repeat speaker at Data Science Sydney. And, well, you'll hear more about Luke in his introduction. There'll be good things to say about both speakers, and all well deserved. Luke has stepped up, and he, as an actual employer of data scientists, and having been one for quite a while, and incidentally also one of the most serious business users of AI that I know in his business microverse, think Luke will speak very authoritatively on the question of data science careers that some of you have come to find out about, but he might drop a few things about AI as well, so that's a bonus. So, on to the main show, and to introduce our first speaker, who may be appearing on the screen fairly soon, is presented to us quite a number of times before, well, go through the credentials. He's a distinguished researcher and real-world practitioner and leader in the AI space. I'm not even sure if I'm supposed to call Dimitri a data scientist. I'd say he's an AI expert, and that's a thing in its own right, though he's a pretty good data scientist as well. The thing about Dimitri is, and perhaps the origin of this talk is explained as, you have people who are sort of your gurus, you have people who are your go-to people for certain topics, and when it comes to AI in particular, the one person who helps me stay up to date on AI and tells me things I wouldn't even have found in the popular literature, even if I went looking for them, which all turned out to be very real, very relevant, is Dimitri. And arising from those sorts of conversations, I thought, well, wouldn't it be great if you shared some of the rather surprising, indeed shocking, recent developments with Data Science Sydney, which he was very happy to do. So I should also mention that Dimitri has a PhD in computer science, and he's a fellow of the Institute of Actuaries, and he's the head of AI for Cover Genius. And there's probably a whole lot of other good things I can say about Dimitri as well, but let's get on with the show. Over to you, Dimitri.
Well, hi. Yeah, thanks, Eugene. Yeah, sorry, I think I can't really see the audience, but that's all right. So yeah, if you recall, I think I think it was in May, last year. So we talked about kind of how, well, at least how technology developed up to GPT-4. I mean, since then, I think we've had well, if you follow this space, we've had quite a barrage of let's call them that, of AI development. Some of them more important than others. If you happen to be associated with the AI news topic on YouTube, I think you'll get several videos a day talking about shocking developments. Huge week in AI, the world is about to change, and so on. I think now we are in the final countdown. That's the current stage of AI development. The final countdown is, of course, due to the cryptic tweet from Sam Altman in response to Jimmy Apple's an anonymous account saying, "Patience, Jimmy, it will be worth the wait." That's the latest on the state of AI. But that's not really what we are here to talk about. We're really to show, I guess, to show with some examples. Oh, just to check, maybe Eugene, do you know, is the other slides coming up okay? Just want to the slide change. Yeah, good. Okay.
Yeah, we can see them.
Yeah. So I mean, what would make for a truly huge week in AI? And well, if you think about it, of course, it's the ability to self-improve to some degree. And it's unclear whether the standard LLMs current generation of LLMs perhaps can't self-improve without help. However, I mean, all pieces are really already there, as I will show today. So with nothing, knowing absolutely nothing, but very rudimentary prompting, you can really create I guess a genuinely self-improving AI system, at least restricted to a particular task. which I will introduce in a second. So it's really the simplest possible task, which is, I guess, text classification. However, my contribution to this was really minimal. All I did is just concatenated some text files and pasted them in, and then pasted things back. That was about the intellectual level at which I was involved. And I mean, the performance really does improve. So, I mean, it's not difficult to extrapolate that with a little bit of help. I mean, the next um, perhaps even the very next generation of AI systems, given a particular task, will be able to go about systematically about assess, assessing own performance and trying to improve it. Um, so, um, okay. So the problem I will use as the example is an item kind of a string text classification problem. So we have item descriptions in the form that they appear on invoices, and we would like to work out whether those items are eligible for an insurance offer, extended warranty. And the generally, to be eligible, an item has to be a physical, non-perishable, or consumable item. So something like um, a loaf of bread wouldn't be considered eligible for extended warranty. Neither would perfume or the like. Some car parts with expected lifetimes are a bit of a more, like tires, are potentially more difficult, although um, yeah, we don't really have to deal with this. And of course, we have to. The reason we want to solve this as a linear classification problem is just because we have to have a pretty rapid pretty quick response, because it has to appear whenever you refresh the page. And since we like, if you use one of the embedding models, you get basically the text converted into vectors um, of, well, at least 1,000 dimensions. You want maybe, if let's say a few 10,000 or more examples to make sure your linear classifier is saturated. You're not losing accuracy just from the uncertainty there. Now, to create this data set, uh, just naive prompting, apologies, with GPT 3.5 gives you accuracy of about 70%. You do get about 90 with GPT-4, but that's that doesn't provide such a dramatic gain, so I wouldn't demonstrate. So maybe, how could we go about it? Well, the way to do it is to change the prompt. Um, Instead of just giving the definition, you could add examples, and perhaps ask to reason step by step, those sorts of things. So basically, prompt modifications. But how do we go about systematically searching, or searching for at least a better prompt? Well, there was this recent framework called DSPy, which is, I guess, a way to, and I'll talk about it in a second, actually. Um, yeah, I'll introduce the framework in a second, and just quickly to show what the data set looks like. Yeah, data set contains of really two relevant fields: item descriptions and whether the item is insurable. It looks something like this. So you have your item description and, insurable true. I guess can opener, sure, why not? The freeze, some sort of low voltage fridge, sure, insurable, and so on. VIP membership is not insurable. Whatever these are contact lenses. These are also not insurable. So that's just this data set with a few, just about 100 examples was put together manually. Okay, so what is, yes, so this talk isn't really about GSPy per se. In fact, it could be some other framework, but just GSPy happens to be the framework that's specifically about prompt optimization. As a warning, it's probably not really ready for production use, but so I wouldn't recommend using it for production, but it could be good for prototyping and so on. It has some interesting concepts. Anyways, so it's an attempt to make the kind of working with LLM-based systems look a bit more like PyTorch, even though, of course, it's nothing like PyTorch really, but it has a similar structure, conceptually has similar structure. So it has modules and it has optimization step, similar to the way you define your network structure, then you run an optimizer. So the modular structure in PyTorch, you have mappings from tensors, then you have modules, and then tensors. You can chain modules together, provided, of course, you have to make sure at runtime that the dimensions match up or it doesn't work. And in GSPy, you have these input fields and output fields, and you can have intermediate steps and kind of a graph structure. In our case, input field is just the item description, and the output is whether it's insurable or not. But we could have intermediate fields if we had a more complex structure, like we could generate reasoning, then we could critique the reasoning and so on, and then kind of reflect and make final. So we could introduce a more complex kind of dialogue structure. And there are different module types that are already built in. And then we talk about optimization, right? Within the in PyTorch, you would have your different losses, like the sum of squares or cross entropy, and you have the optimizers, whether it's just the gradient descent, Adam, or variations on Adam. Yeah, and we minimize the loss over the training set. And in this DSPy framework, we define a metric which tells us on the set of examples that we have, how to compare an example with the output generated by the LLM. It can be the exact match. It can be approximate match, like you can count how many keyword overlap. You can basically define whatever metric you want. Then there are different optimizers that are built in, and an optimizer is just a way to perturb the prompts essentially, or the prompts that the modules generate, and then see how it affects the metric. Of course, it's not real optimization. It's very much sort of heuristic optimization. You don't have a gradient, so you just really reduce to kind of changing things. But potentially you can do it greedily. So maybe you can have a progressive improvement in a multi-chain situation. Now, if you actually go to the DSPy website, you will find there is a lot of, it's a little bit complicated. There is, especially if you read the paper, there is all this talk about parameterized prompts, compilation, teleprompters, assertions, and the examples. Even though you think classification is the simplest example, they don't actually have that example in their repository. So that's and in fact, I've tried to figure it out for quite some time, but the progress was was elusive. Um, so but what you turns out what you can do, um, is we can in fact overcome at least I was able to overcome my personal limitations in trying to address the to figure out how this framework actually works by concatenating the GitHub repo into a single string and pasting it into another LLM. I think that's where the level of anyway, it was I was quite surprised that this worked, and indeed, the you will perhaps so should you be. I mean, it truly does mean that we can't be far away from reliable self-improvement if these things essentially work out of the box. So my contribution was really this basically a Python method to go through the GSPy GitHub repo and concatenate the files. So I put the README file at the start, and then directory structure, and then just dumped all the files in. Now it resulted in a fairly sizable file of of about 4 or 5 megabytes, but there was a bit of binary stuff, so I had to anyway restrict the file types to be only Python and so on. So a little bit of compression was needed, but not a lot. I had to delete about a third. And after that, what was possible to do? I've simply pasted this concatenated GitHub repo and the CSV file with the examples into the new Anthropic model. And this is, I think, the shocking part. It generated a working example 0 shot. Are you shocked? Well, I was pretty shocked. So that's really all I did for this presentation. Okay, which is yes. Okay, so what does that? And I mean, this one. Um, so yeah, so that takes about 2 minutes, right? And I'm pretty sure that there is no classification example in the examples. Well, I couldn't find it. And I had to add it, like initially just created the examples in the code. So I just asked, please make sure read them from the CSV file. And I also wanted to compare it to a naive strategy. And this is what I got, right? So basically, we can quickly have a look at the code that plot 3 has generated. So just to give you an example, just to give you some sense for how this framework works. So we define basically our match function. So this is our metric, and basically the metric, you get a 1 if your ground truth matches the prediction, and otherwise you get a 0. So that's very simple. And then we define this item classifier DSPy module, okay, that basically just based on a simple chain of thought prompt. Then we read in the CSV file of the type we've seen before, define our, say that we're using GPT 3.5, create, again, I really don't know what the teleprompter is. I think it's probably, that's what DSPy calls it, but I think it's really more like an optimizer. So it's basically, this is the method for generating few short prompts that works together with chain of thought. So it basically gives examples of reasoning in the prompt itself, which is pretty interesting. And this is the very simple example where you just give 5 labeled examples from the data set and inserted it to the prompt. That's kind of our baseline comparison. And then essentially you just evaluate the accuracy. So that's all. But basically, I said, well, essentially this entire script was generated zero shot based on the request. Please give me an example. So that's okay. And then when I run this, this is what I get. So the simple prompt where you just provide the examples of insurable and non-insurable items. 5 examples gives you this score, and the one that DSPy has generated using this particular optimizer with these parameters has accuracy of 91%, which, by the way, like a handcrafted prompt that I had for GPT-4 to do this, also gave about 91, 92%. So it's basically we're getting now on this task similar to zero-shot GPT-4 performance. But what actually happened? Well, the generated prompt basically includes, in this case, I think 10 examples of basically reasoning. This is, for example, here we have item description, then we have the which is this, then we have reasoning. Let's think step by step on how we can determine this item from that appliance. Since it's a common household and risk associated, we can say that it's insurable. I mean, again, this is not really a particularly amazing reasoning, but when these reasoning examples are generated, at least it makes sure that the output is correct. It doesn't actually check that the reasoning is correct. And also in this example, I haven't modified the example to actually add hints about what insurable means. So there are all sorts of limitations, but basically this is the prompt, and the prompt for GPT 3.5 contains 10 examples of reasoning taken from the data set, comparing it against the baseline, which only has item descriptions and the whether it's insurable or not. So that's really the kind of what we've seen, right? We've taken a problem and by using LLMs with some additional knowledge being, I guess, the research or thinking that the DSPy team has put into it, we've essentially been able to construct a system that's to some degree self-improves. Now for DSPy, now, all that said, I think it's still worthwhile checking out DSPy a little bit more because it's really great for prototyping complex LLM workflows. So, for example, you can look up, like this is, I think, a couple of months old. There was a paper called Alpha Codium, which is kind of like this LLM prompting strategy to improve performance on coding tasks. And it looks pretty complicated. You basically you enter problem description and tests, and then it generates the plan, critiques the plan, generates solutions, ranks solutions, generates additional tests, and so on. So it's all a little bit, and then it has this this step actually, which is actually trying to test the code that's been generated. So you actually run the code and so on. So partial and not complete, but partial implementation of this quite a big exercise to write with prompts and kind of string manipulation. You can write that in about. I think just 1 second. I think I lost that German. I'll bring that up. 1 second. Yeah, I just want to show what it looks like if we okay. There we go. So this is the entire kind of a good part of the DSPy implementation for this algorithm, which is very straightforward. And I guess if you understand the typing, it can be a interesting thing to try and prototype more complex LLM-based systems. So that's really the main thing. But I guess the big conclusion from this is that, I mean, you can clearly see that with the language models with large context windows, right, you're essentially able to provide enough context to, even though the models themselves aren't trained on DSPy and so on, because the model implementation is actually after the training date, even for Claude, you're able to kind of get the models to more or less learn how to use themselves. I mean, it's not perfect, but we're very, very close, right? And that's perhaps to date, this has been the biggest limitation when you're working with something like GPT. Sure, it can write Python code, but it's been very, very bad at running like OpenAI API Python code. But I think with this large context models that are better at instruction following, probably the next Google release, the 1.5 Gemini release is allegedly very good at that as well. We will be able to essentially use LLMs to help us build LLM-based systems. And I think that will significantly accelerate applications. So that's, I guess, the main thing I wanted to show today. Hopefully everyone's shocked by the huge delay.
I think you'll agree that was indeed pretty shocking as advertised and very to the point. So any questions, folks? Everyone's shocked. Well, in the absence of questions, and where are you anyway, Dimitri?
Oh, I'm in San Francisco.
Oh, geez.
Which is, that's right. It's, I guess, appropriate.
Well, we'd better leave Dimitri to it then. So please join me in thanking Dimitri.
Yeah.
Have a great day in San Francisco.
Bye. Bye. Yeah, it's late at night, but tomorrow promises to be okay. All right. Bye-bye.
11:30. Bye, Dimitri. Well, we'll have our customary 5-minute break. Let's make it 10 minutes because we finished earlier than normal. And then we'll have our next speaker. And then pizza's still available. Lives in
Lost track of it. I just looked up at the
yeah, I
actually came up with a question that was too late. This one here.
AI is able to
That case, it was interesting because it kind of worked in the fact that understood the general landscape and was able to apply some foundation.
How are you finding use case?
It's very similar.
It's exponential. Not so much of the actual. Like I have to the team. I guess.
But then, like,
Pretty much everyone's team.
Yeah, that's true.
Occasionally people feel like
Is it like prompt tuning or?
I guess like
That's a new like seek and stuff.
Yeah, because jazz is deep.
How like
Look at that. That's pretty cool.
That talk to
yeah, just
Common short.
Building a recommendation engine. Asked him how he did it. He's like, oh, I just asked Chat. Look at it sting if someone's studying recommendations. I remember it was like,
Exactly what he was saying. Like, I wouldn't really recommend. It's just like a bunch of academics.
I would talk you a little bit.
It's like comparing he was like
functionality and like making it actually
No, I'm curious because
the shape of it.
it helps with like the boiler.
yeah, that's right. Yeah.
Tweaked him, or like he just said input output.
You're studying a lot.
There is like very strict because it means no, I use it to like you train all like
Almost bad.
so it's like I was just
I was even annoyed at people.
The guy hanging on
Yes, learning SAS is not very good. And I was like, no, it's not.
it's got the name.
Very really reluctant to do.
So fair.
But after I kept trying to change things, end up doing anything. Yes.
Usually the things
Why do you? No, I'm alright.
even like no,
It probably is, and the actuarial
I only picked up
I'm on the second. I worked
it was like
and the IAG.
It was run by
like the stuff he was doing. I understood
You don't need much,
or like
but that was more.
I was gonna ask, like, have you tried
The two parts of the
and then they bring like you still
I don't really use it.
it's fine. Jealous of it.
I used to.
I'm kind of too many stuff.
It is still.
I mean, which insurance
Like I said, I know, right? Okay, it works really well.
in that sense, it's unfortunately the NDIA.
Usually when we test pipelines or models,
Everybody gets his
yeah, basically.
Look it up. iOS, I think web apps and stuff like that.
I know a few people, my old manager.
Containers go once you make
Maybe just
It is very frustrating.
like registry or just
I don't know, just we have a honestly like
You sound professional.
I agree with you.
or some
market scale perspective. Even then, it's like super expensive for people. Can't seem to get away with it.
Like people say it's bad now, but like
it sounds like you're doing in terms of like maturity. It seems a bit lighter on. It depends on what you are.
It is. Indeed, that's true, right?
be asking your.
I don't want you out with one.
Nah.
Asking questions. Fine, but
Yeah, the party. Nice to have Those are.
But we definitely like.
That's the right way to
Right. Yeah, I mean.
we see that in
I normally wake up.
the people at the NDIS who
Recently, I've been doing my data.
for help.
The technical things of ITA.
good, yeah, you like that. I want to stick on ICA.
But it was like,
I was fine.
All round.
Zoe, can you use that
Feels
spell
really
again?
stylish, something like
Wonderful.
current level. The salary survey. I just realised it's a big analog.
Last chance to grab some pizza. I think the drinks are gone at this stage, aren't they?
A few years now.
No drinks, sorry, just pizza.
That's
We don't want you inebriated for the second speech. So, as I told you at the start of the presentation, our announced first speaker is unfortunately unable to attend due to COVID. And the good news is we were able to not just secure a second speaker, but a fantastic replacement speaker in the form of Luke Metcalf, who has presented to Data Science Sydney many times before, and I do hope will continue to do so. And yeah, introducing Luke is a challenge. Let's see if I can do it justice. So Luke is, first of all, the most serious user of AI in a business context that I know of. Now, that may not be the main topic of his talk, but I suspect he will allude to it because it has bearing on how he interacts with employees. Luke has been intimately involved in data science as his career for literally 4 decades, and in those decades he hasn't been a wage slave, he's been an entrepreneur. He's been a successful serial entrepreneur, building, making profit, and from and occasionally actually successfully exiting online businesses with data science at their core. His most recent effort, Microburbs, is something I'm sure we'll be hearing even more about. It's very well known, it's very successful. I should also say Luke is a celebrity. Luke is frequently seen in print and TV media, where his opinions on the real estate market and other things highly sought after. So I hope I did you justice, Luke. And Luke will give us a perspective on a topic that is of interest to quite a few of you, which is the question of, well, what does it take to be a good data scientist, a successful data scientist? Over to you, Luke.
Hello, everyone. Eugene is great at introductions. That was an awesome one. Thank you very much. Eugene, as was mentioned, Eugene messaged me just yesterday to come up with a talk, and I thought it was a really worthy topic. Sad that Greg couldn't make it, so I thought that I would honor the people who are coming to this room and wanted to hear this. And so as much as possible, I'm trying to give Greg's talk, but I am an entrepreneurial data scientist, a startup guy. I'm not a recruiter, so it is going to be a different perspective. And consulting in data science as well. So I'm a guy who is on the tools, but also managing people. So a big thing that I'm going to get across in this talk, I hope, is that data science is a messy business, and it is for the curious and tenacious. So whether you want to take that to be data science isn't for me, or this is the direction of like how I should become a data scientist, how I should open my mind, that is up to you. And I will gently nudge you to other disciplines or in the IT space, like data engineering, if data science is not for you. And if we have, I didn't time this, mic's going in and out. I didn't time this, but perhaps some job application tips, because at Microburbs, we have a ridiculous amount of data, and that attracts, like moths to the flame, that attracts a huge number of data scientists. So I see a hell of a lot of data scientist resumes. So I can tell you a fair bit about, here we go. Mic 3, testing. What to expect if there is time. So I'll conduct my own survey. Can anyone, can I get a show of hands for people who are studying computer science or IT? Okay, a couple. Majoring in data science or masters of data science, couple. Studying something else. It's a bit of an older crowd than when I wrote this. So, okay, we've got some probably some couple of mature age students there. And out of people, obviously most people here have an existing career, but out of those, who are thinking about switching to data science? Okay, there's a few. Yeah, I was all the hands went up for the AI before, but that's good. So when Eugene first showed me this event, shocking developments in AI, advice on moving to a data science career, I joked to him, don't you mean out of? Given what's happening in the world. Obviously, there's a lot of concern. I remember last time I was here, there was a couple of data scientists that were actually saying, I studied this, and they were just starting out, and they were like, oh my God, this ChatGPT is going to take away my whole career. I was going to show a video here, but for technical reasons, I won't. But basically, this guy is showing you, he downloads some Bitcoin prices in a CSV file. There are no explanations, and the thing does a great explanation and does all kinds of analysis for you without needing any kind of coding skill, just the ability to write it. And if you don't know, what Code Interpreter does is you can ask things in English and get guidance on how to do the analysis, and then in the background, it's actually running, I think, Python. Yeah, it's Python. That the user doesn't have to see. So it's actually executing Python and doing analysis for you. So that's something to keep in mind, particularly if you're wanting to start out as a junior in data science. I'm not saying for a moment that Code Interpreter is perfect, but if you're being interviewed by someone like me, I'm thinking, what can this person answer that I can't just get from ChatGPT? So yeah, maybe the hype is dying down, maybe not. I tried to cherry pick the ones that were making it like it was, but still there's a lot of excitement. There's a huge number of graduates coming out in data science, and I think that data science is by no means dead. It's still very hot. I have to do this slide. I have to do this slide in almost every talk. But when we're talking data science, we're talking about this intersection of stats, computer science, and business and domain expertise. And much of this talk will be about, hey, look, why is business and domain expertise important? And if you accept that it is, then maybe that's great if you already have an existing career and you have actual domain knowledge about stuff that you can bring to data science. But if you really just want to be in the code, just in the numbers, then you might consider data engineering. So you might say, look, I'm not a marketing person. I'm not a salesperson. I didn't do a comp sci degree to deal with people. Sometimes in interviews, people have actually said that. I ask them, why did you do data science? I don't like people. Okay. You build models and it's fun, yeah? So you copy stuff from Stack Overflow or GPT and you get a result and it feels like magic. I get that. And so data scientists do machine learning, and data scientists supposedly earn the most money. So I've heard that if you add the word analyst to any degree, you add 20 grand to your salary. So obviously then, and people still advertise for data scientists. So that looks to me like a pretty good mathematical formula for like, okay, therefore you should become a data scientist, yeah? I'm going to illustrate this with a problem, which is like a mashup of a few corporate gigs that I've had. So if you imagine you're working for a fast food chain and they need a strategy on how to get more customers. And they're detecting people's mobile phones as they're going by the stores, and they can map it through some magic to their loyalty program, yeah? So imagine you've got this table where it's like the loyalty ID, latitude, longitude, where they are, when, and then subsequently whether they actually purchased. So this is a very classic kind of data science problem called a propensity model, like what influences the chance of someone purchasing. Now I want to illustrate to you now that about 20 different ways in which you can create a model that is super accurate and also completely useless. So first to cover off, data is messy, yeah? So imagine you've got all these stores, they're franchises, they're installing different hardware at different times, they have different territory managers, and some Wi-Fi routers will be more powerful than others. So food courts, for example, you're more likely to brush by the router than if you're actually in a store. So the conversion rate would look heaps lower for that. iPhones might not be providing identifiable MAC addresses. So one solution to this is to go, okay, I can't really look overall for the whole country because this is patchy, but if I control for the store and the time of day, so like what are the influences that affect the chance given a particular time of day? So if one customer walks by and buys and the next one doesn't, and then I look at the delta and the percentage chance, that is one way of doing a model to overcome this otherwise very crappy data. But let's assume that the data is clean. What would we find? So all the time I see people submitting models based on data, and particularly when it's commercial stuff, and they report that they have 98% accuracy. I say, good on you, but 98% is pretty high. Let's look into this. So one thing is, most naive of all, there's a 0% chance unless you're within specific lat-longs. So obviously, congratulations, you found where our stores are. 0 chance unless it's specific times. So they've discovered the concept of opening hours. The customer is not yet excited. Greatly increased chance around noon and evening. So you're probably that means that you're probably one of the 20,000 cultures in the world that has dinner and lunch. No great excitement. This is a one that isn't so obvious, but comes up all the time. So I often ask people, these user-based models, a model will actually often find that a low user ID is actually a better customer. And the reason is because very often user IDs are incrementing up. So customer 1 has a ID of 1 and so on. And for them to be remaining in the database and to be continually there means they've had a recent purchase as well. So people who bought a long time ago and recently, and they signed up to the loyalty program, they are great customers. That's fine, but this is not very actionable stuff because you can't then create more customers in the past. Yeah, so there's not much to do with that. Here's another one that we had. So whether they received a push notification. So I was actually at a company where the marketing department was very proud of a particular campaign that they'd done. And even more so, they mixed it into all the other stuff. And they were saying how they got a 50% conversion rate. But what had happened was people had already walked into the store at the point. So it's like at that point, you bloody well should get a conversion. Yeah, they've already decided to make that. So this is what's called the attribution problem, which you have a lot with banner ads as well. So it's like you put a banner ad in front of someone who's already going to buy. So what I would usually do in my consulting, and this is how I always beat the internal people at machine learning, not because I learn them better, like I learned the internals of the organization, not because I have a degree in behavioral economics, not because I have the most complicated models, like I don't compete on Kaggle, I don't have some amazing model ready to go. It's because I just combine with other data sources that when they don't think to do that, they're only using internal data. So you could get the competitor stores, yeah? So the idea would be if you just walk past a Macca's, then you're less likely to have KFC, yeah? And you know they'll be sharing it among more people. But what you might find is, well, they could be put there for a reason, so that doesn't really tell you how many people are there. Is it, what's the ratio of stores to interested people? Foot traffic, car traffic. So that will give you a sense of what it is. You could join to the user table to get profile info. So we saw before we had a loyalty ID. I've seen this one where I joined to a user table, but then it turns out they keep updating the user table. Yeah. So if you have last visit date in there, the model thinks it looks like a genius model here. It can predict with super accuracy, but the person has purchased, it shows up in the user table, the model comes along and says, aha, I can identify exactly who's going to come in. And so, you know, obviously you've got to always check that you're looking backwards in time. Home address. So you take with the loyalty data, you get usually a home address. I used to do a lot of this in my consulting, still do, where you know to 120 households basically how they filled out the census. And out of that, we got a very powerful model. So for every extra year of education, propensity declines 15%. In other words, they don't want smart, educated people. That turned out to be the strongest predictor of eating this fast food. So, and you know, these things, like, it's very common. I say this not just for entertainment reasons, but also to get across the idea that what you find in reality is often very different to what the customer is telling you. So, yeah, obviously what I was describing there didn't sound very techy. I'm not showing any code. I am a coder, but doing that code level stuff doesn't tend to go well with the business clients that I would consult to. So I would like to, you're right, I do. Well, the bottom one, yes. Yes, so data engineering is more this deterministic kind of thing. So if you want a spec and you want to go build something, then I think that's a great place for you. Productionalization of data science models may be sort of in between, but the actual main hard work is in working out getting models to actually work in the first place. So you think data engineering, you're creating pipelines as infrastructure, whereas for data science, you try out lots of different stuff, all kinds, throw lots of data at stuff. The main value is in the feature engineering, just trying out until you find stuff that works, and be prepared to throw away loads and loads of code. Yeah, just don't get attached. So data engineering integrates into the process of the organization. You know, it's critical infrastructure. Data science is more like open, it's discovery. So if you want to be cynical about all this stuff, like, this is how you should present yourself if you want to get a job in data science. Obviously, I'm a startup guy, so maybe I'm more this way, but I did actually, the last DSS thing I did, I was on a panel where there was another guy, Tristan, who was at a business with about 30 employees, and there was the head of data at Canva, and we're all saying pretty similar stuff. So I think this will get you, obviously Canva's not an old school big corporate, they're a growth business, but I still think this says something also where corporates are going. So yeah, the following are specs, delivering time, maintaining uptime. Now here I'm not just talking about how you're different to IT, but how like living inside IT isn't necessarily always going to work for you as a data scientist, yeah? So they only care that the systems are working. They don't care that much about historical data. They don't care that much that the vendors changed and this column here and that column there. Whereas as a data scientist, you're always looking backwards in time and you want to go far back in time, right? You don't want to do just the last 12 months. You want to see the seasonality and what happens on Mother's Day, etc. You want to, particularly if it's a low volume client, you just want loads and loads of volume. Throwing volume at the problem is way easier than going hardcore on statistics and is much more reliable as well. So yeah, they change versions and they don't care about the last stuff as long as the system works. So whereas, yeah, you will need to capture other data sources as well. So data quality, so there's assumption, oh, you just give me good quality data and then we're sorted. But all the sources of data have different views on what good quality is. So being business aware really helps you in data science. So like I mentioned, IT, if the product works, they're doing their job. Finance, they have all of these like old school standardized ways of doing analysis, and you know, the aggregates have to all add up and they need to double entry bookkeep and stuff. But usually they're not getting to the granularity that you want as a data scientist. And BI, so their job is to put out dashboards and have them not reported. Very often they'll be aggregated and it's like very, very stakeholder focused. Sales, they obviously want to know their commissions, who to call next. Marketing wants marketing to look good, so they need to be able to say that their campaigns are working. And customer service, obviously getting people off the phone and getting good ratings. So none of the, and I'm sort of breaking things down into concrete terms here, but all of these different areas and many others have all kinds of different abstractions that serve them and where they've come from, and they don't all nicely go together. So what a customer is and what a transaction and what a product is are not obvious when you go to a large company. That's why you should be talking to people. I'll give an example in my current business, Microverb. So I'm doing a lot of real estate forecasting. And one of probably the most golden rule of the real estate market, so looking at capital growth over time, is mean reversion. So what goes up must come down again. So we've got data going back to 1990. That's the biggest thing of all, is much more than momentum, which most people think. Things go back. So suburbs that are trendy for a while, they go back. So that means that you could very easily find a pattern to prove anything if you pick the right dates. But then if you look at the subsequent period, if it's the same time period, you might find that it's actually you could have completely the opposite finding. If I had a bit more time, I would have shown I have this graph, which is correlation of postcode, thinking of postcode as a number, and capital growth, and it's this sine wave like that. So it's like, you know, WA and South Australia going awesome, and then it's Sydney, right? So other way around there. Yeah, so there's another example, like you need to a hell of a lot of domain knowledge to be doing real estate analysis. I posted this one up before. So obviously data science is maturing, and so you've got on the left side more this hype-driven approach to data science, where you take an input table, you just make the assumption that it's clean, it's not your problem if it's not. Bring in some bleeding edge models, and so that you can pad out your resume and sell it as another step towards deep AI. Don't worry too much about the business assumptions. You're a techie, that can go later. And at the end of the day, your manager gets to grow headcount and you get a better job. What you should be doing, and the people that survive in the space are doing more give me lots of data from lots of different points of view, talk to the business, find out what the hell things mean and what they understand, because they'll know lots of things that aren't in the data. Validate, find the key drivers of probabilities of business outcomes as first principles as possible if you want to get the best models. And then they become actionable insights and genuinely production models that you can rely on long term. Most data scientists, I think, don't. There's some stat was that 80% of data scientists never end up making anything that ships. Yeah. So I like to make things that ship. And a part of the reason is that I have simple models that are easy to deploy, but they're using different data sources. And it's very unambiguous why they should work. So character traits for data scientists. So I think one of the biggest complaints talking to other people who manage data scientists is that they get stuck in rabbit holes. They go down certain tracks and you need to keep pulling them up. So there's a lot of self-discipline involved in saying, look, I'm going to do this. I'm going to explore this for an hour. And if it doesn't bear any fruit, I'm going to check in and just be prepared to throw that away. Beautiful thing about Jupyter Notebooks is that they are these sort of this throwaway medium. You don't feel too bad. It's not the same as if you're building a massive Java object relational map or something. Yeah. So yeah, you need to have a lot of discipline. You need to check yourself and be able to criticize yourself and where you are. What I like to do is write comments as if I was describing things to the client. So it's like a client who doesn't understand code, a client who doesn't care about things that are like novel and efficient, the client who wants to make money. So empathy. You don't have to love your customer. You don't have to be great friends with them, but I think it's very important to understand their point of view. Stakeholders as well, and people often forget about vendors. So very often it's a question of like calling up the vendor and finding out what the hell does this data mean? I found this unusual column. When this column happens to be a blank string as opposed to null, it has a massive effect on the model. I want to know what the hell that means, yeah? So they know valuable things that you don't. So data is not a pure reflection of reality. It's just something that gets generated at certain points along the cycle. And yeah, they're not going to accept your results anyway, unless you speak their language. So you go in and it's like, okay, I'm talking to product people. I'm going to use product language. Oh, these are sales people. Now I use the sales language. And yeah, so understanding what insights help each stakeholder. So part of this game of getting really good data is also about being friendly with lots of people. So you can make a slide deck with 20 slides, and then you'll say, well, who benefits from these? Yeah. So you say to your boss or your client contact, how can we best make use of these? Because there's going to be insights that benefit all kinds of people from their political point of view. And in exchange for some favor, you then get data. So yes, this panel, we all mentioned curiosity. So being able to really think from many points of view. There are all kinds of actors that influence decisions, and you have to be quite rigorous about like what are the things that drive these more than others. No one has the full picture. There's always surprises that come through. There are things that they know that you don't. There are things that they know that you'll have to accept that are not in the data. But as far as the data goes, I always find there are massive improvements in model quality to be found that no one expects, no one's saying it. Very often, things like customers are much more specific. So their target market is much more specific than they think. Or something that they said is fixed is actually still broken. Yeah, so many people interacting. Yeah, I mentioned that stuff. Yeah, so you can get at being a polymath. Yeah, so if you have other interests and you have a career in something, I would leverage that as much as possible. Even if you kind of like you're over your career, I would really try and think about the bits that you enjoy, go off and analyze them, keep that with you. That will give you the edge. Yeah, so for me, like I'm interested in markets and human behavior, particularly where there's a large number of humans. I'm interested in obviously real estate and geospatial, but I would never do a physics or a chemistry or biology thing because A, it doesn't interest me, and B, I wouldn't even be very good at it because I have very little knowledge of that stuff. I think it's a mistake to just take on any customer or employer just because they have data. So yeah, I think I illustrated before, it's very easy to come up with a model that has great precision and recall, but is complete crap. So not usable stuff. So customers can shoot down your analysis very quickly if you don't know what you're doing. So they may know better. They know about specific examples. Your analysis may simply be bad. Your data, the input data might be bad. Or maybe the insights are okay, but no one can relate to it. Nobody gets it, yeah? So I always like to do role plays in my head. So it's like, if I say this, what would they say? I have a mate who's a sales guy, and we like to do that to and fro. Mapping out in your head various approaches. So cost versus benefit, time to code versus insights. So yeah, I think I mentioned before, machine learning engineering should be probably about 10, 20% of the job. I think that's a fairly standard view. There's rapidly diminishing marginal returns. So you can put more effort, get your gradient boosts in there, and you can get a little bit better, but the massive cost is you might not know what's going on. It may be overfitted. So it's like, it seems good, but it's really not. And so I would be much more into like, I'll very happily give you a decision tree that you can turn into a if then else. Like for me, that's the ultimate thing for the client, or a simple regression. Yeah. Something that they can use. Doesn't have to be if then else. It's like, oh, okay, I'll just target those customers. That's a big win. And why bother productionalizing something big and expensive if you can just like say, hey, just go target them. Obviously, if you are doing deep research, so obviously you can earn a huge amount of money if you get a job at OpenAI. This is not what I'm talking about in this talk. I'm talking about, us regular people in a tier 2 city of Sydney, regular corporations that they got business problems. Yeah, they're marrying the tech to the business. That one. So yeah, I would say harness. So where to start? What I would say is harness your passions. So even if you're a student and you don't have any career to lean on, maybe you love cricket, yeah? So I get really, really sick of seeing in job applications, uni assignments, they don't know about what the hell they are. You ask them about it, it might be a group work. I learned to not even ask about uni assignments. I want to know about something that you care about. You probably don't care about irises or the Titanic, but you might care about cricket or Taylor Swift, elections. Maybe you're a political nut. I don't care. It can be something really esoteric. It could be, your micro niche on Tumblr. Whatever it is, I want to see some passion, and I want to see that you have gone in and done some analysis. Because if you are going in and the data means something to you, if your cricket hero got 200 runs, that's actually something that resonates with you. It's not just a number, and that way I can see that you are really trying to like own and be the analysis. It doesn't have to be a perfect analysis, right? I don't expect you to be the next advisor of the Australian cricket team, yeah? But if you can at least talk about it and think about it and have your own perspective, and also very important is to be able to talk about, okay, if you had more time, what would you do? And I love to get in and like look at the analysis and then suggest different angles and see if they're like receptive to that. Oh, okay, that's interesting. Building a web-facing project end-to-end, so some sort of data dashboard thing. We hired a guy who did that. He got in the SMH, really good guy. He came up with his own analysis. So some sort of dashboard with insights. Like if you've done a project end-to-end, particularly for me in startup land, that is a really, really, really good sign. That you interface with customers and you had to think about that there are many different users of this rather than just your lecturer or just having more code on GitHub. Yeah, post on social media your findings, getting feedback, just so that I can see actual real feedback is really good. Claude, we saw in the last one. So I was quite inspired by that last talk to dump our code base into Claude and get it to find all the bugs. So I think obviously another thing you can do to, if you want to get into this, is like talk to the LMs. Everyone should be doing that these days when they want to learn, particularly if you're at a earlier stage. So, but 101 on anything, I think these LMs are extremely useful, and getting that critique on your code. They're pretty good at like looking at variables. So they seem to be better than the average human at like looking at a column name and inferring what that might be, even though it's a string. So, oh, it's like that Bitcoin example. It was like inferring what would be the buy price and the sell price, even though it was just a couple of letters. And yeah, so I would advise not making a total clean break. I would really leverage what you already have. So don't think of data science as this pure thing where you're becoming a machine learning monk. I think it very much in terms of just having more power and more tools to build on what you already have. Broadly speaking, I credit Eugene for talking about this with me, where we often talk about how to hire good people. So the philosophy of critical thinking, yeah, not taking things for granted, scientific method, take a step back. And then broadly speaking, if you've got an area of interest, then there's numerous books that you can look at. So economics, behavioral economics as Freakonomics, or politics, the signal and the noise, morality, culture. These are really good books. There are going to be many more based on your interest. But if you take an interest and then you search for that interest and statistics on Amazon, I think that would be probably a good start. And you would wow the interviewer being able to genuinely be passionate, not just ChatGPT said you were passionate in the cover letter. I reckon about more than half of all applications now, either it's ChatGPT or it looks like it. And you get really sick of vibrant, dynamic, they're just throwing in everything. Like, I don't know who you are. Why don't you just say specifically what you've done and what you are, as opposed to something else? You're not just like awesome at everything. If you can, obviously this gets easier as you get more senior, but talk to players in the target industry. So if you can talk to your interviewer, particularly if they're more senior or they're a founder, how are data scientists perceived? There are different industries with different lays of the land. So actuaries are very powerful in insurance. They've been around for a long time and they provide great service, of course, love you guys. So actuaries are doing similar work to data scientists. So if you understand that, you understand the industry that you're presenting to, that you're trying to get into, that goes a long way. So are the data scientists really doing the work that you expect? Very often they end up just cleaning spreadsheets and doing IT stuff. They might have to go build a dashboard, because people get hired on the hype, but then they just aren't that useful. They can't be put to use. So obviously you're not going to, a lot of these things I describe here, obviously, I'm 47 years old. I wasn't doing all this stuff when I was 20, but if you think about where are you going in your career, I think you could start by, a way of thinking of it is you start with the rigor. So you'll have as your peers, technicians, machine learning engineers, statisticians, and then you move into over time, you in the organization spend a lot of time with the stakeholders, and then you're in the company of BI consultants, innovation consultants, leaders, and then finally driving change. So actually having a voice, having something to say, being someone who's respected in the organization is like, oh wow, that guy, he calls it as he sees it, or girl, and we can rely on him for genuine knowledge. And it's a beautiful place to be. There aren't that many other people in that middle there, yeah? So you can be driving change like a thought leader, you could be applying rigor like a regulator, but if you've got all of those things together, then I think that's a really powerful place to be. And I would imagine there'll be ever more data scientists ending up taking over, becoming the CEO of organizations. I mentioned about the ChatGPT cover letters. I was thinking the other day, maybe I'm going to put, every time someone sends me a ChatGPT cover letter, maybe I'll put that back into ChatGPT and say, what was the prompt they used? Maybe down, among the 3 paragraphs, maybe there is some little nugget. I hate having to go through 3 paragraphs to get, oh, wow, you actually did something. You actually asked someone, yeah? So just don't do it. More broadly in general, like ask your, this particularly for the uni students, ask your friends, how are you applying for jobs? Whatever they do, don't do it. Do different stuff. There are so many, like, okay, we have a lot of data, so it's very easy for us to attract data scientists. We get a lot of them, but yeah, I would like just run a million miles, attract attention however you can. All these buzzwords. I asked GPT just for a list of them. Innovative, cutting edge, analytical, data driven. It's really hard for me to read this. This is like passionate is huge. Yeah. My favorite is proven, a proven ability when there's no such proof. Yeah. It's the exact opposite. Yeah. So I would, in these cover letters, I would just get straight to the point. Why are you different from most of your peers? Then in the interview, I ask, so why do you want to join microburbs? And then they say, well, I did this and then I did that. And now I have a data degree and now I want to work in data. Well, that's nice. That's you. What about us? Why do you want to work for microburbs? Yeah. It's like if you, it's like if you're going on a date and you only talk about yourself, what is the date going to feel about you? Yeah. So what are you bringing? So if you only care about yourself in the job interview, why do I think that you're suddenly going to start caring about the company in the job? Yeah. So it's great to have background knowledge on the company. So don't simply say that you want to work for us because you want a career in data. That doesn't make me feel very special. I can tell you, there's a lot of data companies out there. Don't bullshit me. So don't pretend to know something when you don't, because I will ask a follow-up question. And that's just like, so if you're going to bullshit me now, like what's going to happen when some critical infrastructure that you have shipped or you've given me some important analysis, like you're starting the relationship with no trust. So it's like, you're out. I'm very happy when people say, I don't know, but I'm willing to learn. Tell me more about that. A huge thing I use in job interviews is like, are they really going beyond simply what they plan to tell me and what they understand? So can we actually have a conversation? So one thing, if I'm lost for words on what to ask them, I just talk for a few minutes and then I say, just summarize what I just said. Just give it back to me. And that really, people get shocked and they're like, they start saying stuff that they remembered about microburbs from online. Like, no, that what we shipped, that was our business 6 months ago. Like, we're working on new stuff. Tell us about that. Yeah. So seeing things from other people's point of view. So a big question I always ask is like, okay, explain this to my grandmother. Yeah. She doesn't have a degree. She doesn't know what a correlation is. And it is really tough. Yeah. Don't list loads of technologies if you don't understand them. Just really draw attention to unique things. Sample code. Don't like it. Like most of it is just crap. Everyone has it. It's nothing, right? I don't care about your uni projects. I mean, it's sad. I'm sure there are some really awesome uni projects out there, but I think I need like ChatGPT or Claude to get in and find the actual gold in there. That's something that's where they've actually done something extra, because there's so many GitHub repositories. If you tell me it's not a uni project, I'm much more likely to listen to it. So all of this recipe following and sandbox stuff, like, okay, running through the big thing for me, it's like, it's a hard question. Most people can't, but like, show me a Jupyter notebook where you've learned something and then it changed what you did. So you go, oh, okay. Are we running low on time? Or we're good? Yeah. So yeah, where have you actually, you saw something, you saw a graph and you go, oh, it's not really that thing, it's that thing. Therefore, I'm going to change what I'm doing. that level is like, that's the mastery level where I go, I need to pay attention to this person. Yeah, stay away. Like, I don't really care about bleeding edge technology, but like, I want to show that you can actually like make use of stuff and get stuff done. And don't tell me that you got 98% accuracy in something of its own. Like, yeah, I'm sure I could get to 100 if I find an even worse column than you're using. Yeah, so end-to-end projects are awesome. Analysis, so your thoughts, having unique thoughts on things, a growth mindset, these sort of things are really powerful. And like I say, you don't have to have a complete project. You don't have to be a total expert, but you have to be open on how to improve. And wow, I got to the end. Do we have, I'll invite the room for questions or?
Oh, yes, you can.
Okay. Oh, sorry, this is Eugene's job. I'll say it much deeper, more authoritative. Down here.
You need that.
Yeah. Questions? Does anyone have questions?
Do you think there's a difference in applicants for small to large organizations?
Yes. So what I describe here applies more for the smaller than the large, particularly if it's a incumbent large. So there's obviously, sometimes people just need a data scientist. But having said that, here's a point I didn't make properly, is that this code interpreter stuff is catching up to you. So if you're starting out low and if you're not really super valuable, like make sure you've got something that you can bring to a larger organization. Obviously, there are other skills to do with getting along with people and spending a lot of time understanding the structure and things. Yes, I think it would still, I had no trouble getting consulting work in large organizations, despite not being as a recruiter would ordinarily tell you to present yourself. So, I mean, I have helped large organizations hire, and I still carry the same kind of mentality for that sort of job as I do for when I'm hiring for my startup.
I have a question.
Yeah.
I don't have any background in data science, but I like to get into it. And I probably won't have time to go back to uni at this point. But what do you think about boot camps and all this stuff that's around?
Yeah, I'm not a big expert on boot camps. I think if you're interacting a lot with it and you're doing your own stuff, and if you're engaged and if it's up to date, then I think it's okay. So I personally don't look at much about, I mean, having great academic records, great. I don't look that much at other course materials. Probably it's a bit of a plus, but the main thing I'd be looking for is your personal projects. So I would reckon time in general is better spent building stuff and exploring and improvising.
So if you regarding consulting, you have a consulting project that there is not enough data just at disposal. And so what do you do? So because most of the projects, especially in some domains like health, I'm sure healthcare, but some of the domains not that much data completely available.
So if there's not enough data on a project, so typically I have ideas on where to get it from the public domain. So, I mean, I don't do health. That would be another example of an area I don't do because I'm just not an expert. So getting data, there's huge databases out there, and you can provide a lot of value bringing those in and trying to understand how it's helpful. Actually, I did do one health because I'm big into tracking myself, and I consulted to a startup where I brought in 3 years of my own tracking data. So I guess that was health. So there's an example of like, hey, I can bring data to the table, but if there really is no data, so for example, if they're a company that just has a small number of customers, so it's not really statistically significant, and they only care about those customers, then I would say, if it's a small, you might get a statistician like Tom Osborne there for the smaller scale stuff, or you might, I would just say, I don't think you should hire me.
What would be your feedbacks on things? Sorry, what would be your feedbacks on students who are still at uni on a controversial controversial thing of tools versus the field expertise? Because as a data science engineer or as a data science career, there is always a question marks of knowing tools versus the expertise in particular field. So what would be your comments on that?
Yeah, for me, it's base tools. So standard stuff, Jupyter Notebooks, Python, scikit-learn. Yeah, know how to make a graph. So my perspective is I will go for technologies that are very easy to pass on to others. So it's very much on your expertise. Obviously there are going to be other businesses out there that are working on some real bleeding edge technology, but from a business point of view, you're always taking a big risk with that. But you could still, I would still really be looking for people being smart anyway. So very often I've hired people that are great in a particular domain, but then they don't grow. Yeah. So we have actually found that an inverse correlation between commercial experience and success at microverbs. So the people who've had the most years have performed the worst. So being a uni student, totally fine. But yeah, field experience trumps.
Does that mean you're more likely to hire someone younger?
I'm open to all kinds. I'm non-discriminatory, but there tends to be a lot of good people in universities, and yeah, there's a lot of unused talent in part-time work, part-timers. It is said that young people have a particular, if you're young and smart, you have a particular advantage if you can talk to a GPT. I think it's not so much age as like openness to experience, yeah? So you should have that as a data scientist anyway. I am an old man, but I like to think that I am still open to new things. So yeah, you can be old, that's fine. Okay, yeah, so within microverbs, the ability to communicate quickly, we're mostly remote, so the ability to get your message across in a stand-up, to see things from the customer's point of view, to get the tickets done, to be helpful, to get to the point, not to go down rabbit holes, to take ownership of things, to be able to do things from end to end. So yeah, we're really about hiring very smart people who can just really run with things, and people who want to learn, people maybe they want to run their own business one day, or at least they want to have the autonomy. There's a big trade-off. You can give a lot more autonomy to people if they're very capable, and we can have like we only have 3 pages of rules. That's our company process. Apart from obviously legal stuff, occupational health and safety. But in terms of like the stuff we're looking at every day, so you have a small number of simple rules, you can move much faster. So, and these rules apply to everyone every day, as opposed to having a large number of rules that apply in very specific circumstances.
Yeah, my turn, I think. In the last few years, I've come across companies that are doing AI and data science within full stack and using things like Databricks. And I compare that with other workplaces which are more holistic or seamless, or the business units like to talk to each other. Have you got any advice about whether you should choose to go to the full stack kind of players or the data science as a component within the business as a whole?
Okay, so Databricks versus, so yeah, like big vendors with lots of stuff. We have been given a whole lot of free hosting credits from Amazon, so we're learning more about them, but the base is very much on simple, open source, commodifiable technologies for us. Maybe I'm not answering your question fully though.
what I've seen in a couple of Databricks environments is they specialise the roles of the staff quite narrowly. So there's data scientists, there's machine learning engineers, there's machine learning something else, and there's people between the data engineer and the data scientists. And some of those people talk outside the business unit, and other people.
Yeah, I would never allow that. So.
Oh, good.
Yeah, everyone does everything. So I'm always really looking for generalists. I think in this era of AI, you can complement your skills much more easily. So I've got a guy who's he graduated and he's become something like our CTO now because he always knows what GPT has to say on any subject. So I think there's an amazing ability to grow as a person. So when they say everyone gets a promotion, I think that's true. Like I think that's a open AI thing. I mean, as a startup, obviously, as you grow, a business grows, it needs more processes, and you need to have clear lines of responsibility. So I can't pretend that a company with 100,000 people can operate like we are, but we'll try as long as possible for people to be as generalist and like no bullshit, no abstractions, just like we're here to help customers, explain things in simple but clear ways. That is how we grow.
Please join me in thanking Luke for a terrific presentation. And before everyone runs away, we have our customary announcements, and in particular, anybody with jobs going is welcome to come and announce. Luke, do you have any good jobs going you want to announce?
Yeah, sure. Generalists don't even have to be data scientists. So just like very smart generalist people who want to do lots of different stuff in a startup and have loads and loads of different kinds of tasks in a day, who doesn't want to be constrained to a single thing. We are open to that, as well as really, really good data scientists.
Thanks, Luke. Any other announcements? They don't have to be jobs, but anything you'd like to share with the class? And since there ain't, thank you all very much for coming. Thank you again to the Institute. Thank you, Zoe, for supporting us as always. Thank you all. See you next time.